Dear students, today we will discuss about salt gel process. This process is used for the fabrication of nanoparticles and nanolayers. There are different types of approaches that is for the fabrication of nanolayers. Basically, there will be top-down approach and bottom-up approach. In top-down approach, the starting material will be a bulk one, that is bulk material, macroscopic. Then it will be break into small particles, and that can be again split into nanoparticles of size 1 to 100 nanometer. But at the same time, for bottom-up approach, the starting material will be atoms or molecules. Then these atoms are combined to form clusters. Then these clusters are grouped to form nanoparticles. That's the basic difference between top-down and bottom-up approach. And our salt gel process is based on bottom-up approach. It is a chemical solution process, and it is used to make ceramic sheets, oxide layers, semiconducting materials, and they are in the form of thin films, fibers or powders. The sol means it is a liquid state of colloidal solution. It is a colloidal or molecular suspension of solid particles of ions in a solvent. The solvent from the sol, it begins to evaporate, and the particles or ions, they will left behind to join together in a continuous network, and this semi-rigid mass or the jelly-like stage of colloidal solution, and it is called the gel. Now I will explain about the processing steps. The metal alkoxides or the chlorides, they are typical precursors here. They undergo hydrolysis and condensation to form a colloid, that is a system composed of nanoparticles which is dispersed in a solvent. Then the formation of metal oxide involves, that is connecting the metal with oxo or hydroxo at the centers, that is MOM or MOH M bridges. So through the hydrolysis and aging process, aging means we will keep the solution for hours in undisturbed form. Okay. So we can generate metal oxo or metal hydroxo polymers within the solution. Now we can remove the solvent. So through the drying process, there is a remaining liquid will be vaporized, and we will get the gel. Finally, the gel is grinded to form fine powders of nanoparticles. Now we can see the chemical reactions. First, there will be hydrolysis of alkoxy groups. This is metal alkoxide. R represents the alkyl group. So the metal alkoxide plus water, and we will get MOH, metal hydroxide, and this is salt. Okay. After the aging process, that is if we keep the solution for hours, there will be reaction between alkoxy groups, that is condensation, that means MOR plus MOH, we will get metal oxo metal, MOM, and this is gel. And we can evaporate the excess liquid, and we will get the solid nanoparticles. The same procedure is shown here. So at the starting, metal alkoxide and alcohol, they are mixed. When this metal alkoxide, when it is completely dissolved in alcohol, we can add water to the solution, and we need to mix it very well. And this is homogeneous solution. So after the hydrolysis process, there will be formation of metal hydroxide, that is MOH, and this is called as salt. And they are not soluble in water, and they are colloidal particles. Then after the several hours, there is a aging process, there is condensation and the formation of MOM chains, metal oxo metal, and this is the gel. So after the drying, that is vaporizing excess alcohol and water, we will get the dried gel. Now we can grind this gel. After grinding, we will get smooth powder of nanoparticles. Now we can wind up the session. So this is an important topic. There is a sol gel fabrication method, and it can be asked for your examination. Okay, thank you.